For the first time in over 50 years, humans are going back to the moon. Today, we're going to break down the incredible Artemis 2 mission, a journey that is kicking off a brand new chapter in space exploration. 53 years. I mean, just let that sink in for a second. For over 5 whole decades, not a single person has left Earth orbit to go visit the moon. That long silence is what makes this mission so historic. It's not just another launch, it's really the beginning of something entirely new. So, on April 1st, 2026, there it was, the massive Space Launch System rocket. Now, there was a tiny little delay, had to clear a faulty sensor on the safety system, but then, my gosh, the most powerful rocket NASA has ever built just roared to life, absolutely ripping a hole in the sky. And who was on board? A really amazing international crew. You've got Americans, Reed Wiseman, Victor Glover, and Christina Cook, along with Jeremy Hansen from Canada. They named their ship Integrity, which is a really cool nod to the global teamwork that made this whole thing possible, right down to the service module built in Europe that was keeping them alive. Okay, so once they got into orbit, they kind of hit the pause button. See, this was the very first time this particular Orion capsule had ever flown with people inside. So you better believe they ran a full systems check in the safety of high Earth orbit before committing to that long trip to the moon. And this really highlights how far we've come. The Apollo guys, they were dealing with actual life-or-death mechanical failures. The Artemis 2 crew, well, their biggest headaches were a broken toilet fan, which meant using a backup bag, and, get this, not being able to log into their Microsoft Outlook accounts. Talk about a 21st century problem, right? So, with all the systems checked out, Mission Control gave the go for what's called the trans-lunar injection burn. This was it. This was the point of no return. A huge engine blast pushed Integrity right out of Earth's orbit and set it on a path that would swing it all the way around the moon. They pulled this off using an incredibly smart flight path called a free return trajectory. Basically, instead of flying straight there, it uses the moon's own gravity like a giant cosmic slingshot. It just whips the capsule around the far side and then flings it straight back toward Earth. It's brilliant. And it's the most fuel-efficient way to do it. At its most distant point, the crew was over 250,000 miles from home, 252,000 miles to be precise. That is farther away from our planet than any human being has ever been, period. And can you imagine the view from out there? Wow. The crew said the moon literally filled their entire window. The commander's analogy just nails it. He said it was like holding a basketball at arm's length. While they were looking at the surface, the crew saw something amazing, these newly found bright spot craters. And mission specialist Christina Cook's description was just perfect. She said they were so bright, they kind of look like holes poked in a map shade. That's the kind of beautiful detail you only get from a human observer. And that really gets to the heart of this mission's scientific value. It wasn't just about testing the spaceship. It was about sending the most advanced sensors we've got, our own eyes, to see the moon up close. I mean, we have some incredible cameras, right? But even the absolute best digital sensor only captures a tiny fraction of what's really there. Reality is just so much richer, so much more detailed. So here's why their view is so critical. Our eyes can see a massive dynamic range. That's the difference between the brightest brights and the darkest darks, and a huge spectrum of color. A camera sensor, it just can't keep up. It loses all that subtle detail, which makes what the crew saw with their own eyes absolutely priceless. So what did they actually see? Well, they said the moon isn't just gray. They saw distinct shades of brown and even faint hints of green in some of the craters. They described the landscape as this rough, complicated world of huge peaks and steep cliffs, especially on that heavily cratered far side. And as they looped around the far side, it was just one historic moment after another. They were the first people to ever see the entire 600-mile-wide Orientale Basin. They watched the Earth set behind the moon, which put them in total radio silence. Then, they captured a new generation's Earthrise, and, as if that wasn't enough, they saw a 54-minute total solar eclipse from a viewpoint nobody had ever had before. After 10 days, it was time to come home. And this is, without a doubt, the most dangerous part of the whole trip, re-entry. The capsule has to hit the atmosphere at an incredibly precise angle. If it's too shallow, it'll just skip off into space. Too steep, and it burns up. There is just zero room for error. As it slammed into the upper atmosphere, the capsule hit a blistering top speed, 32 times the speed of sound. The friction at that speed is it's almost impossible to imagine how hot it gets. So the re-entry sequence is this fast, perfectly timed dance. The service module separates, the capsule flips to point its heat shield forward. It gets engulfed in a 5,000-degree plasma field, which cuts off all communications. And then, once it slows down, the main parachutes pop out for a soft splashdown. For 6 agonizing minutes, there was just total silence. That plasma field makes communication completely impossible. Mission Control, and pretty much the whole world, could do nothing but hold its breath and just wait. And then you hear it. A voice breaks through the static. The crew was safe. Their absolutely staggering 695,081-mile journey to the moon and back was almost over. Integrity splashed down perfectly in the Pacific Ocean, right off the coast of San Diego. The recovery teams moved right in, and one by one, the 4 astronauts who had journeyed farther than anyone before them were back home on Earth, bringing their historic mission to a close. The mission was just a huge success. It proved the hardware works, that humanity can travel into deep space again. But really, this was just the first step. Artemis 2 proved we could visit. The real question it leaves us with is, what are we going to discover when we finally go back to stay?